Python's file handling capabilities allow efficient reading and writing of files, crucial for data management. The JSON module simplifies working with JavaScript object notation data, enabling seamless application programming interface integration. Mastering these skills enhances data manipulation and storage, essential for robust application development. Explore intermediate file handling in Python, focusing on mastering file operations and JSON handling. Learn how to manage data effectively and integrate APIs using Python's JSON module. This chapter will enhance your skills in robust data management. File handling is crucial for data persistence, allowing information to be stored and retrieved beyond program execution. It facilitates data exchange by enabling reading and writing of structured formats like JSON, CSV, and XML. This is foundational for APIs, configuration management, logging systems, and data pipeline development, ensuring seamless data sharing and application functionality. File modes dictate how files are accessed: R for reading, W for writing, A for appending, and R+ for both reading and writing. Binary modes RB and WB handle non-text data. Context managers, using with open as file, ensure files close properly, even during exceptions, safeguarding resources and data integrity. Reading files can be done entirely or line by line using R mode. Writing new content uses W, which overwrites, while A appends data. These operations ensure efficient file handling, crucial for data management. Understanding these methods is essential before addressing file exceptions and robust error handling. Handling file exceptions is crucial for robust applications. Common errors include file not found error, IO error, and ISA directory error. Use try except blocks to manage these. Attempt file operations in try, catch specific exceptions like file not found error, and handle them gracefully. The else block executes if no exceptions occur, and finally ensures cleanup, maintaining application stability. The JSON module in Python simplifies working with JSON data. It allows for easy conversion between JSON strings and Python objects using functions like json.load, json.dump, json.loads, and json.dumps. This module is essential for handling data interchange in web applications, ensuring seamless integration and data manipulation across platforms. JSON, or JavaScript Object Notation, is a lightweight, text-based format for data interchange. It's human-readable and easy for machines to parse. JSON is language agnostic, widely used in web application programming interfaces, and supports nested structures with minimal syntax. Key elements include objects, arrays, strings, numbers, booleans, and null values. JSON objects map to Python dictionaries, arrays to lists, strings to str, and numbers to int or float. JSON booleans translate to Python bool, and null to none. For example, a JSON object like user, Alice, age 30, active, true, becomes a Python dictionary with active as true. Python's JSON module is essential for JSON serialization and deserialization. Use json.load to convert JSON files to Python objects, and json.loads for JSON strings. Conversely, json.dump writes Python objects to JSON files, while json.dumps converts them to JSON strings. Remember, functions with S handle strings, those without handle files. To load JSON data, import the JSON module. Use json.load to read from a file, and json.loads to parse a JSON string. Access nested data by specifying keys, like user_data, open bracket profile, close bracket, open bracket email close bracket, or user_data, open bracket orders, close bracket, open bracket, 0, close bracket, open bracket, product, close bracket. This allows efficient data extraction from complex JSON structures. To write JSON data to files, use json.dump for direct serialization with optional formatting. For instance, serialize a dictionary to student.json with indent =4 for readability. Alternatively, json.dumps converts Python objects to JSON strings, ideal for transmission or storage. Adjust the indent parameter for desired output format. Pretty printing JSON enhances readability by using indentation, making it ideal for debugging and human review. Use JSON.dumps with indent equals 4 and sort underscore keys equals true for a structured output. Conversely, minifying JSON reduces file size by removing unnecessary whitespace, using separators, comma, colon, to create a compact format, optimizing storage and transmission efficiency. Nested JSON structures often involve complex multi-level data. For instance, a user profile may include nested objects like an address and an array of orders. Understanding these structures is crucial for effective data manipulation, allowing you to access and modify specific elements within the hierarchy efficiently. Nested JSON structures often include objects within objects and arrays of objects. For instance, a user profile may contain an address object and an orders array. Each order is an object with details like product and price. Understanding these structures is crucial for effective data manipulation. To access nested JSON data in Python, load the data using json.load. Use dictionary chaining to access nested objects like user address city for the city. For arrays, use list indexing, such as user orders, to get the first order. Loop through arrays to access each element, printing details like product and price. To modify nested JSON data, update values directly, like changing city to Cambridge, or setting an order's status to delivered. Add new keys, such as country, or append new orders to arrays. Always save changes back to the file to ensure data persistence. Directly accessing non-existent keys can cause key error exceptions, risking application stability. Use the deact.get method to safely access keys, returning a default value if missing. For nested structures, chain.get calls to prevent cascading errors, ensuring robust data handling without crashes. Advanced JSON handling involves custom serialization and deserialization. Python's JSON module can be extended to manage non-JSON serializable objects like datetime or complex numbers. Implement a custom encoder to convert these objects into JSON-friendly formats. Use object hook in json.loads for custom decoding, transforming JSON back into complex objects seamlessly. Python's JSON module can be extended for custom serialization. Use a custom encoder to serialize datetime and complex objects. For instance, datetime is converted to ISO format and complex numbers to a dictionary. For deserialization, use object hook in json.loads to reconstruct complex numbers. This approach ensures seamless handling of non-native JSON objects. Handling large JSON data can strain memory, risking crashes. Libraries like iJSON offer streaming solutions, parsing data incrementally. This approach is ideal for files over 100 megabytes or in memory-limited environments. For instance, iJSON processes large arrays without loading them entirely, enhancing performance and reducing memory usage. Consider streaming parsers for efficient large dataset management. JSON validation is crucial to prevent errors like trailing commas, single quotes, or missing brackets. Use safe JSON load to handle JSON decode error, file not found error, and unexpected issues. Always validate JSON syntax, especially with external data, to ensure robust error handling and successful parsing. Integrating JSON with web APIs involves fetching data using HTTP requests and parsing JSON for data retrieval. For instance, a REST API call retrieves user data, which is then parsed to filter active users. A summary is created detailing total users and active usernames and saved to a JSON file for future use. Utilize context managers with open for efficient file handling, ensuring files close even on errors. Implement try-except blocks for JavaScript object notation parsing to manage malformed data gracefully. During development, use pretty printing for clarity. Minify JavaScript object notation for production. Access nested JavaScript object notation safely with .get to avoid key errors, ensuring robust data handling. Explore JSON path and JMeS path for efficient querying of complex JSON structures. Practice with APIs like GitHub and OpenWeather to enhance your skills. Build projects such as configuration managers and extract, transform, load pipelines. Dive into schema validation with JSON schema and optimize performance with iJSON. Utilize resources like RealPython and GitHub for further learning.